In this preview lesson, we will be previewing section 3.4, the special cases of solving linear equations. And in class, we will call these the ox cases because we usually will see 0x, which looks like the word ox. Some very important vocabulary in this section. Well, to start from a previous section, we know that a solution is the answer to an equation. We can plug that in to check. But in this special section, we will see solutions or answers that have special names, like identity. That means that all real numbers, that's what this symbol means, will work when you check to see if they are solutions. Or no solution will work when you plug it back in to check. And here's the symbol for no solution. In class, sometimes we talk about this being like a stoplight, that there are all real number solutions, or no solution, or maybe one solution. And so that will be x equals and then some number. Let's take a look at these two example problems. They will show us our two different cases. Again, I'm going to draw my line down the middle. I might do it for both. I see some like terms on the right-hand side this time. Always circle with the sign in front. Combining my like terms, I get 5x. Going to bring down the rest. Try to stay as organized as possible. Remember, we're aiming for letters on one side and numbers on the other. Using my inverses, I'm going to get rid of the 5x first. So what I do to one side, I have to do to the other. Notice that we are going to get 0x here. That's the ox case. And 0 times anything is 0. And 0 plus 4 is just 4. So I'm not even going to write 0x. But that's going to be the indicator that this is going to be a special case. Since these canceled out and these canceled out, all I'm left with is 4 equals 5. And we all know that 4 does not equal 5. I could still subtract 4 from both sides, or I could even subtract 5 from both sides. But all those times, we are going to get a false statement. And whenever we get a false statement, our answer to the problem is going to be no solution. There is no number that you could plug back in for x and check that will make it a true statement. Let's take a look at the example below. I see some like terms. I'm going to deal with those just like I did above. Bringing down everything else. And using my inverses to get rid of the 5x. I notice that they disappear here like they're supposed to. But again, they also disappear here. We tend not to write 0x because 0 times x is 0 and 0 plus 4 is just 4. Mathematicians are sometimes lazy, so if we can understand the identity, we can just skip that step. This time, however, we end up with a true statement. A true statement tells us that we have an identity. It is always true in an identity. So our answer to the problem is going to be the symbol, all real numbers. No matter which number you plug in to check, it will make a true statement. Good luck on your special cases.